In order to find normal distribution probabilities where we have normally distributed data and the mean is not 0 and the standard deviation is not 1, what we need to do is make sure we give the last two inputs to normal CDF using those values. So nothing much changes here. We still use second and the distribution menu to find the normal CDF function, and the stat wizard brings up the four inputs that it needs. It's still lower bound, upper bound of our shaded region, and then the mean and standard deviation. The only difference here is we'll fill in something for the mean and standard deviation. So here's an example problem. Suppose a normally distributed set of data has a mean of 34.5 and a standard deviation of 5.2. And we'll find the following. So first is the probability that x is less than 28.1. And it's important to note that we're asking for the probability of x. So we would be working on an x-axis instead of a z-axis. So that sort of is a hint that we're using a normally distributed set of data where the mean is not 0 and the standard deviation is not 1. So I'm going to note that the mean here is 34.5 and the standard deviation is 5.2. Alright, so the mean is still located right in the center. And if I were to label any tick marks outside of this, I would label them in terms of the standard deviation. So for instance, this next one would be like 39.7, for instance. But that's more than what I need to do. I'm not going to go and do those. Important thing to note is that this is an x-axis and not a z-axis. So if I want the probability that x is less than 28.1, I just kind of place 28.1 where I think it might be, and all the x values that are less than that would be to the left of it. So I would shade that region. So I need to go from negative infinity to 28.1 for my shaded region. That would be my lower and upper bounds. And as I start putting that into the calculator, of course, what we'll do is indicate the negative infinity with negative, then second comma to get the e, then 99. So that means negative 1 times 10 to the 99th power. The upper bound would be the value that we use for our upper bound, 28.1. So 28.1. And then the mean was given in the problem as 34.5. And the standard deviation was 5.2. When we hit paste, it puts that all into normal CDF for us, and when we press enter again, it will calculate that probability. Now, if we want to answer the other types of probabilities, this would be a left tail probability. We could also do a right tail probability. The only thing that would be different is that if we want values that are greater than 32.4, as in this case, we would start our shaded region at 32.4 and then go to positive infinity. And that's what we'll do. So second distribution, normal CDF, 32.4 is the lower bound of our shaded region. The upper bound is positive infinity, so E99. And the mean and standard deviation are not changing, so I'll just paste all that, press enter, and it calculates the area of that shaded region, which is how we interpret the value of the probability that we want. Now, lastly, if we need a between probability, the nice thing here is we don't need to worry about substituting any values with positive or negative infinity. We just use the values as is. So back into the distribution menu, normal CDF, 37.7, whoops, force of habit there. The upper bound was 41.2, and the mean and standard deviation are not changing. So run that, and we'll get the probability that we need.